Hi everyone. Today we're going to study partition of a set. Let us define partition of a set. A partition of a set is a collection of mutually disjoint subsets whose union is the original set. If A is a finite set, then the subsets A sub 1, A sub 2, up to A sub n of set A form a partition of A if, number 1, the union of the set A sub I, where this I is equal to 1 up to n. To expand this, we may write A sub 1 union A sub 2 union A sub 3 union up to A sub n. And this unions is equal to the set A. Second condition, set A sub I intersect A sub j. This is equal to a null set, for I is not equal to j. This idea of partition is also described by this illustration. Let us see this theorem. Let R be an equivalence relation on a set A, and variables A and B are elements of set A. Then the following statements are equivalent. Number 1, A is related to B. Second, the equivalence class of A is equal to the equivalence class of B. Third, the equivalence class of A intersect the equivalence class of B is not equal to null set. Let us see this further definition. Let R be an equivalence relation on a set S. Then, the equivalence classes of R form a partition of S. Conversely, given a partition with set A sub I, such that small I is an element of capital I of the set S, there is an equivalence relation R on S that has the sets A sub I, where small I is an element of capital I, as its equivalence classes. Let us see this example. Find the partitions of the equivalence relation congruence modulo 4. Finding the partitions means finding the disjoint equivalent classes of congruence modulo 4. The best way is to start with the equivalence classes of 0, 1, 2, and so on, until the classes are repeated. Let's begin with the equivalence class of 0 of the relation congruence modulo 4. We know the elements of this equivalence class. Here are the elements. Next is equivalence class of 1, and the elements are here. Followed by equivalence class of 2, and we will write the elements like this. The equivalence class of 3, and the elements are now here. Take note that if we're going to write the equivalence class of 4, note that the elements will be the same as the equivalence class of 0. Therefore, since the classes are now repeated, we're going to stop here. Therefore, the disjoint equivalence classes are 0, 1, 2, and 3 of the relation congruence modulo 4 respectively. This is now our final answer. I hope you learned something from this video. See you again next time.